Question number 14. In the diagram below, ABC is equals to 90 degrees, AC is equals to 13 units, BC is equals to 5 unit, and CD is equal to 6 unit. Find the length of AB. Okay, so first of all, we have to find out the length of AB. This is AB, and we are trying to find out this length. AB is a side of the right angle triangle ABC, and ABC is also a side of the right angle triangle ABD as well. What I am going to do, I am going to consider triangle ABC to find out the length of AB. Why am I considering ABC and why am I not considering ABD? Because in ABD, I only have the length of the adjacent or the base. So with only one side known, I will not be able to calculate the length of AB. So I can only consider triangle ABC, and in ABC, I know the length of the adjacent B to C, which is 5, and I know the length of the hypotenuse A to C, which is 13. I have the hypotenuse, I have the base or the adjacent, whatever you call it. Okay. I can use Pythagoras theorem to find out the length of the perpendicular or what you call opposite. So according to Pythagoras theorem, hypotenuse square is equals to base square plus perpendicular square. Hypotenuse, as we all know, is the side opposite to right angle triangle, opposite to right angle. So hypotenuse becomes 13 square. Base is 5, so 5 square. Perpendicular is AB, which is unknown. 13 square is 169 is equals to 5 square is 25 plus AB square. In order to find out the value of AB, I'll first of all remove this 25 and move it to the left hand side. This will be 169 minus 25 is equals to AB square. 169 minus 25 is equals to 144. So AB square is going to be 144. In order to find out the value of AB, I'll need to get rid of this square. So I'll take a square root on both the sides. This square will cancel the square root. I'm left with AB. And the square root of 144 is 12. This is going to be 12 units. Then part B. In part B, we are supposed to find out the angle ACB. This is angle ACB, which we have to find out. Okay. Now, after doing part A, I have this side as well, which is 12 unit. I have to calculate the length of ACB. I can use trigonometric ratio here to find out that unknown angle. And which trigonometric ratio? The trigonometric ratio, which involves maybe opposite and hypotenuse, maybe adjacent and hypotenuse, and maybe opposite and adjacent. As all the three sides are known now, I can use any one of the three trigonometric ratios that we have learned. So in part B, I am going to use tangent theta. Tangent theta, the angle which we are trying to find out is ACB. So instead of theta, I am writing ACB. Tangent ACB is equals to opposite upon adjacent. Opposite is 12 and adjacent is 5. 12 upon 5, you may divide it or you may leave it just like this. In order to find out the angle ACB, I'll take tangent inverse of 12 upon 5. We remove the tangent from this side and shifted it to the right hand side, it became tangent inverse. What we are going to do, we are going to use calculator to find out the tangent inverse of 12 upon 5, or maybe you can convert it into a decimal, which will be 2.4. So ACB is equal to 67.38. This is 67.38 degrees. Last part is finding out the value of the angle DAB. DAB. Where is DAB? This is going to be DAB. Okay, the line coming from D to A and then going towards B. So we have to find out the angle DAB. Since we are trying to find out angle DAB, the only thing that we have is considering the triangle ABD. If I consider triangle ABD, I'll have to make sure that I know two sides of the triangle ABD. The two sides of triangle ABD, which I know, one of them is this, which will become opposite, and the other one is the adjacent, the length from point B to point D, which is going to be 5 plus 6 is equal to 11. So I can calculate the value of DAB according to this angle. DAB 12 becomes adjacent and 11 becomes opposite. I do not know the hypotenuse in right angle triangle ABD. So the only trigonometric ratio which I can use here with opposite and adjacent being known, that is tangent theta, and in place of angle I'll write angle DAB, tangent DAB equals to opposite upon adjacent. Opposite in this case, as I have already mentioned, is 11 upon adjacent is 12. In order to find out the value of DAB, I'll take tangent inverse of 11 upon 12. So tangent inverse of 11 upon 12 is going to be 42.51 degrees. So angle DAB is going to be 42.51 degrees. That is your question number 14.